Hello, Sir Parts online subscribers. Welcome to Sir Parts I Teach Learn Machine Learning in W3 Schools. Please do not forget to subscribe and ring the bell so that you could get the latest videos of Sir Parts online. And today's topic, we're going to discuss about the multiple regressions in W3 schools. Okay, so we have in the previous topic, we learned about the polynomial regression. This is the polynomial regression. This one is a diagram of a bad fit. This one is a good relationship, and you can predict the future with that. And okay, for today we have multiple regressions. Okay, multiple regression. Multiple regression is like linear regression, but with more than one independent value, meaning that we try to predict a value based on two or more variables. Take a look at the data set below. It contains some information about cars. The car, the model, the volume, the weight, and the CO2. We can predict the CO2 emission of car based on the size of the engine, but with multiple regression, we can show in more variables like the weight of the car to make the prediction more accurate. Okay, how does it work? In Python, we have the modules that we will do the work for us. Start by importing the pandas module. Import pandas. Learn about the pandas module in our pandas tutorial. The pandas module allow us to read CSV files and return a data frame object. The file is meant for testing purposes only. You can download it here. Okay, so we're going to click this one, guys. We're going to click that. And there you go. I already have that data.csv. Then make a list of the independent values and call this variable x. But put the dependent values in a variable called y. Okay, it is common to name the list of independent values with uppercase x. So, and the list of dependent values with lowercase y. So x is the independent values, the weight and the volume. And so you have there the weight and the volume as x now. And the y is our CO2. Then we'll use some methods from the skill-learn module. From skill-learn, import linear model. So from the skill-learn module, we'll use the linear regression method to create a linear regression object. So this is the code for that. And this is the whole example in action, the code. Okay, this is the whole code, guys. Import pandas from skill-learn, import linear model, df equals pandas.3.csv.data.csv, x, that is our independent variable, weight and volume, and our dependent variable is the small letter y. That's why it's called dependent. And the independent is weight and volume. So when we run, the result is 107.287328. So I predicted that a car with 1.3-liter engine and a weight of 2,300 will release approximately 107 grams of carbon for every kilometer it drives. Okay, that's the code. You can click the run example so that you could have the result. By the way, this is the data.csv. .csv, guys, is comma separated value. So we have the car, the model, the volume, weight, and CO2. And you have all the data here. Okay. So what's next? So we have coefficient. The coefficient is a factor that describes the relationship with the unknown variable. Example, if x is a variable, then 2x is x 2 times. X is the unknown variable, and the number 2 is the coefficient. In this case, you can ask the coefficient value of weight against CO2 and for the volume against CO2. The answers we get tells us what would happen if we increase or decrease one of the independent values. For example, here we have print the coefficient values of the regression object, import pandas from skill-learn import linear model, df equals pandas.read.csv data.csv. And that's the result. Um, let's click the run example. And as you can see here, you have import pandas from sklearn, import linear model. So we have our data here and the weight and the volume. And this one is the value. So we print the result of the coefficient. As you can see, we have 0.0075 values. And what does it mean? It means that the weight is 0.007, volume is 0.07 also. These values tell us that if the weight increased by 1 kilogram, the CO2 emission increases by 0.00755, and also the engine size increased by 1 cm cubic meter, the CO2 emission increases by 0.0072 gram. I think that is fair guess, but let's test it. So we already predicted that if a car with a 1,300 cubic meter engine weighs 23,000 kilograms, the CO2 emission will be approximately 107 grams. What if we increase the weight with 1,000 kilograms? So we copy the example from before but change the weight from 2,300 to 3,300, and we show the result, that is 114.759. We predicted that a car with 1.3-liter engine and a weight of 3,300 kilograms will increase approximately 115 grams of CO2 for every kilometer it drives, which shows that the coefficient of 0.0075 is correct. So that's the formula, guys. So that is multiple regression. I hope you learned something today, and please tell us about what you have learned in this particular topic, multiple regression. So please feel free to comment so that I could know what you have learned so far. What are your challenges? We could chat that. We could help each other in learning. Thank you very much. This is Sir Pars Online, your lifelong learning buddy. Bye.